Compound interest. The interest earned is added to the principal, making the principal bigger. Notice the formula is different. By the way, this formula is the one you use if the problem's about inflation. So this is the compound interest formula. This is the present value. This is the future value. So PV would be the investment or loan. Future value would be the future value of the investment or loan. R is the rate. T is the time in years. And we have a new kid in town here, M. So if compounded daily, the M is 365. If compounded weekly, the M is 52. Compounded monthly, then the M is 12. Compounded quarterly, the M is 4. Semi-annually, the M is 2. Annually, the M is 1. One way you could think about it, as soon as they say compounded weekly, ask yourself, well, how many weeks are in a year? Compounded quarterly, well, how many quarters are in a year? And that would be these numbers you have here. And that's the way you select them. Suppose the rate for an account is 0.85%. Find the value of the account. If $10,000 is invested for 1 year and interest is compounded quarterly. So notice compounded quarterly was what was underlined, because this is going to tell us it's this formula. That's the way you could tell it's this formula. Compounded daily, weekly, monthly, any of those, it would be this formula. So you write your correct formula, choose your correct formula, and identify what they're giving you, what part of the formula they're giving you. Suppose the rate for an account is 0.85%. Well, that's the R. Find the value of the account if 10,000 is invested. That's the PV. For 1 year, that's the time. Compounded quarterly, that makes the M of 4. And so we're looking for the value of the account. In the future, we're looking for FV. You plug it into the respective places, and you get a future value of $10,085.27. So this 10,000 in the future, when this amount of time goes by, is going to turn into this amount in the future. The 10,000 will turn into this amount. Compounded continuously, the key word here is continuous. When you see the word continuous compounding, this is a formula you should be writing. So you identify your correct formula first. Suppose 5,000 is invested in a savings account at an annual rate of 3.1%, compounded continuously. So at this point, I know it's this formula. For 4 years, find the compound amount. So now you go through your problem and see what part of the formula they're giving you already and what's missing. Suppose 5,000 is invested. Well, that would be the PV. At an annual rate of 3.1%, that would be the R. For 4 years, that would be the time. Now plug it into your formula, and those 50,000 would turn into, those 5,000 would turn into $5,660.08. Effective interest rate, this is a symbol for it, R sub E, or you could call it APY. They mean the same thing, annual percentage yield. What do we use this for? Well, you could compare different rates, different offerings from different banks, and see who's a better deal. What this formula does is you give it the R and the M, and it'll give you back as if it was an annual rate. So it turns everything into an annual rate. For example, we're going to use it here. Which gives you the better deal for your money? Bank A, 1.80% compounded annually, or Bank B, 1.77% compounded quarterly. So you run it through this APY formula. Notice these are the rates. The R's go right here on top of in the numerator position. Compounded annually, so the M is a 1. So you put it here and here. That's what the formula has, an M here and an M here. So the 1 goes in those two places. Compounded quarterly, so the 4 goes in these 2 places. Simplify, and these are the annual percentages you get. This is a better deal. It's more for your money.